Hello everybody, welcome to Thesis 123 where I learn and teach online from anywhere at any time. Now we will discuss about variables. What are the variables and how it can be assigned to the Matlab within the Matlab software. Before that we have to know what are the variables. Now what is variable and what is constant? Before going to know about the variables and constants, I want to take example as a Ohm's law. Ohm's law is defined as that nothing but V equal to IR. This is the simplest form which we can define Ohm's law. Here V is the voltage, I is the current, R is the resistance. Okay. Here I, that is nothing but currents, considered as a dependent variables, whereas R and V, resistance and voltage, are independent variables. Why means here currents are always dependent on voltage and resistance based upon the Ohm's law. Okay. Whereas come to constant, if the values of both resistance and voltages are fixed, those are constants. These are the simplest definition for variables and constants. But before going to know what are the types of the variables, we have to know that what are the variables have been there within the Matlab. Here we have to know importance of the variables and constants. Variables and constants are integral part of a program. That is, they do not change their values during the execution of program. Those are nothing but constants. Whereas the numerical values assigned to the variables are subjected to change. It can be changed at multiple times. Not only that, a variable is assigned a name made up of letters or a combination of several letters and numbers and is assigned to a numerical value. A variable can be used in a mathematical expression, function, or a statement once it is assigned to a value. In most of the programmable languages, the program has to declare these variables in advance at the beginning of the program. Whereas in the Matlab, a variable can be declared and when it is required. A variable can be assigned a numerical value or a character. How it can be done within a Matlab, let's see. Before that, variables can be divided into two types. Those are numerical and character. Numerical variables are also subdivided into integer numbers, real numbers, and complex numbers. Okay. Integer numbers, numerical variables are divided into integers, real numbers, and complex numbers. First, we will go for integers, integer numbers. Integer numbers, right? Here, an integer consists of 0 to 9 with a sign minus or plus. Here, we have to pay attention about that. Use of space, comma, and character are not allowed. Let's have examples based upon the integers. Okay. Valid integers are nothing but 1989, minus 230 or 240 plus 78 or 32, 34, 56. Like this, these are the integer numbers which are valid integers. These are valid integers. Now we will see invalid integers. Invalid integers are nothing but that is use of space, comma and a character are not allowed within the invalid integers. Those are nothing but 22/7. These are not valid. Or 1, 200, that is nothing but 1200. These are also not valid. Or rupees, or pairs 50 rupees. This is also not valid. Or 198 pairs 6. This is also not valid. Or this is also not valid integers. Okay, by giving these ones we can get invalid variables. Okay, you have to note down this one. Use of space, comma and a character are not allowed within the Matlab, that too for integer numbers. Okay, now we will go for real numbers. You know very well, numbers that contain functional part are called real numbers, or floating points constant. All the physical parameters such as voltage, pressure, temperature, etc. as represented using real numbers. For example, here I am showing you 0.04 minus 52.54 or 1035.345 or 42 exponential of minus 4 e power 4 e power minus 4, that is also valid. Or 2 e power 8, this is also valid. These are all the real numbers. These are the examples which we have seen right now. Now we will go for complex numbers. What are the complex numbers? A complex number has both real and imaginary part. Within the Matlab, we can use the suffix I or j. That is nothing but root of minus 1. I or j is nothing but equal to root of minus 1. That too to define the imaginary part. The complex number can be represented using either Cartesian form, that is nothing but rectangular form within the real and imaginary parts, or polar form within the magnitude and angle. You know very well that we can use that rectangular form or polar form. That is nothing but rectangular form can be defined within the real and imaginary values. Polar form can be defined within magnitude and angle. Now we will see some of the examples based upon the numerical variables. We have some commands. Let's have a look. Here I am taking this x equal to 2. Okay. Now I want to implement real and imaginary commands. For that I want to assign the values for the p equal to real of x, that is x equal to nothing but 2. Okay, equal to 2 is assigned to the x equal to 2 is assigned to the p. Now p or q equal to EMAG, that is nothing but imaginary value of x equal to nothing but 2. Okay, it's a 0. Why? Means there is no part of complex number, that is nothing but imaginary number is not is there within this x. Or you can see the conjugate values also here, CONJ. of x is also conjugate value also 2. We can see that to give the complex for the magnitude, that is nothing but absolute value, that is nothing but n equal to abs of x. It's also 2. Whereas we have to find angle theta angle of x. It's also 0 because there is no angle within the x equal to 2 variable. And also we have a conversion of coordinates, that is nothing but Cartesian to polar, polar to Cartesian. How we can do here means conversion of coordinates, that is nothing but Cartesian to polar, polar to Cartesian. We can use that commands with nothing but theta comma m is equal to cart to pole of p comma q. Correct? Theta is 0, whereas magnitude as 2. Okay. Now this can be written within the polar form also, polar to Cartesian. Let's say here we are converting polar to Cartesian. That is theta equal to 0 and magnitude also 0. Now we will see the character variables, single string escape sequence. These are the character variables we will see within the Matlab software. That is nothing but here single character variables are nothing but a, b, c and d, all these ones. These are the letters are nothing but singles. Whereas come to string variables, those are nothing but, for example, simplest example, P, LD or good luck. This is also one of the string variables, string character variables. Whereas come to escape sequence, those are nothing but backslash n slash f. These are the escape sequence which we can use within the Matlab software. For this, I want to tell one thing for you. A variable, that is nothing but a variable single or sequence of character enclosed in a pair of single quote is called a constant variable. The characters may be numbers, alphabets, special characters or blank space are considered as a character constants. Those are nothing but explained as examples within the Matlab software. Example for the character variables, you will see that my name is thesis 1, 2, 3. This is nothing but a character constant which is having numbers, alphabet, special characters or blank space, all the things. Okay, these are the variables which we can be divided into two as numerical variables and character variables. In the next video we can discuss about the rules for assigning variables and some predefined variables within the Matlab. Okay, up to that, wait for next video. Thank you so much for watching this video. For future videos, subscribe to our channel, or if you have any queries, just click on www.thesis123.com or follow us on Facebook, Twitter, Google+, or Pinterest. Thank you so much.